The problem in the previous video was about as straightforward as we can get one of these finding the area between two curves problem. So let's do another example that will have a little bit more twist to it. So here I'm giving us two different functions. F of x is x squared minus 5x minus 7. G of x is x minus 12. And I want us to find the area between these two functions over the interval between minus 2 and 5. And so the thing that we're going to want to think about, I'm not telling us which function is on top and which function is on the bottom. Are we going to integrate f minus g, or are we going to integrate g minus f? And as it turns out, that answer is going to change based off of where we are. So the first thing that we want to do, there are several steps that we'll have to do with this problem. So the first thing that we want to do is that we'll want to solve the equation f of x is equal to g of x. So when we do this, we get x squared minus 5x minus 7 is equal to x minus 12. Moving everything to the left produces x squared minus 6x plus 5 is equal to 0. And this factors as x minus 1 times x minus 5 is equal to 0. And so we get two solutions. We get x is equal to 1, and we get x is equal to 5. So these two functions, they intersect at two places when x is equal to 1 and x is equal to 5. And so let's draw some axes. There is a 5, there is a 1, and also we're being asked to go from minus 2 to 5. And so let's put another little tick mark over there at minus 2. Now what do these functions look like? Well, x minus 12, that is a straight line with that, let's see, it's going to, down here it's going to be at, when x is 0, we get minus 12. And so roughly speaking, that is what g of x looks like. Now, f of x is an upward opening parabola, and we know from this little piece of information that it has to intersect g of x at when x is equal to 1 and x equal to 5. And so our picture is going to look something like this. So here is f of x, and here is g of x. So we want to find the area between these two curves on the interval from minus 2 to 5. So the first step was to solve f of x equal to g of x, find out where they intersect. And so now we can, from the picture, tell which is on top and which is on bottom, and note that the answer changes based off of where we are. If we're between 1 and 5, we want to find the area between them. Well, g of x is bigger than f of x, and so we should be integrating g minus f. But if we're between minus 2 and 1, f of x is bigger than g of x, and so there we should be integrating f minus g. And so in order to set this up, let me go ahead and write all of this down. We're doing the integral between minus 2 and 1 of f minus g. And then here we're doing the integral from 1 to 5 of g minus f. So those are the two calculations that we should be doing. Okay, so let's go to the new slide to actually carry out these calculations. So we're looking for the integral from minus 2 to 1 of f of x. So that's x squared minus 5x minus 7 minus g of x, so minus x minus 12. And then we're doing the integral from 1 to 5 of x minus 12 minus, so this was g of x minus f of x, x squared minus 5x minus 7. So these are the calculations, these are the two integrals that we have to do. And so these end up as the integral from minus 2 to 1 of x squared minus 6x plus 5 dx, plus the integral from 1 to 5 of minus x squared plus 6x minus 5 dx. And when we do these integrals, we get x cubed minus 3, sorry, x cubed divided by 3, minus 3x squared plus 5x. We go from minus 2 to 1, plus minus x cubed over 3, plus 3x squared minus 5x, going from 1 to 5. And when you plug in all of these numbers, you get 27 plus 32 over 3. And so your final answer is, oops, not 111, but 113 divided by 3. So 27, that's this area right in here. 32 over 3, that's this area right in here. And adding those together gives you 113 over 3. Okay, let me make some concluding remarks about this problem. There's some things to look out for and some twists that I can throw onto this problem. So thing to look out for, note that both of these answers, this 27 and 32 over 3, note that those are both positive. And that's important because when we're finding areas between curves, we want our answers to be positive. And so if we had got an answer of maybe minus 27 here, that would be suggestive that we had done these in the wrong order. That if we did the integral of g minus f, we get minus 27, and that negative answer there would suggest to us that we've done something wrong. We should go back and check because we want our areas to be positive. So that's one thing to look out for. Another thing to look out for is that a different twist on this problem is that sometimes I might phrase this as just find the area between f and g, and I just say find the area of the region that's bounded by f and g without giving you particular x values. And so I just said find the area of the region that's bounded by f and g. What you should do is you should solve this just as before, figure out where they intersect. And so the region that's bounded by f and g is just this region here. So I said find the area of the region bounded by f and g. You would just have to figure out, solve fx equal g of x to find that they intersect at 1 and 5. So that's what you'd have there. And then just do the integral of g of x minus f of x between 1 and 5. And so that's a very similar type of problem. And so I want you to do an example of that. So I want you to find the area of the region bounded by these two curves, y is equal to 12 minus x squared, and y is equal to x squared minus 6. So you want to find 2 points at which they intersect, and then integrate between those two values of x. And you have to figure out which one, what do you want to do something minus the other one. You have to figure out which is on top and which is on bottom.